So, hi, hello, good morning. Welcome to that Mad One Week 7 activity and practice question session. Of course, some kind of when we are discussing that activity and practice questions, we'll work it on that what is the background concept of it. And let's have a overview of the week 7. Week 7 is not mostly hands on, except that the lab experiment you need to submit. The week 7 is mostly about that memory hierarchies and you know basically how really the backend servers optimization we can do, scale up scale down we can do, that kind of theoretical, more theoretical. I think if you would have walked through that one, I think you can understand, right? Is it that? That's the overview of the week 7, is it right? Hello, hello, hello. Am I in the call? Can you hear me?
Yes, sir.
Yeah, just you give me a thumbs up at least, so that I can know that you are in active state. So the week 7 is mostly theoretical. We don't have hands-on things where you are having different concepts, and behind it, mostly the memory hierarchies and as well as databases and scalability of your servers. That's it, right? So let me share my screen. Kindly acknowledge that. Oh. Mm, yeah, that. So I'm sharing a Chrome tab. I think it's visible, right? Is it visible? What I'm sharing, right?
Yes, sir, it is
Yes,
visible.
sir.
Great, great. So yeah, so let's move to the week 7. But while we are walking through and solving the question, you will understand what really is that. Maybe basically when we are working with 7.1, 7.2, keep working. Yeah. Now, actually, you can take a look, right? So week 7.1 is exclusively advanced state management. Advanced state management means mostly whenever any process, any application it is running, it has to go through that various memory hierarchical devices. Memory devices are there. So some of them have that high performance, some of them have low performance, right? So that we are trying to, yeah, it is a mad one session only, right? Because somebody asking, maybe they joined in a wrong way, maybe it's a mad one. Yeah, sorry. I'm sorry. Maybe I opened a wrong tab. Huh? Okay, okay. Thank you. Or maybe I need to open that. Yeah, it is 2003, right? Yes. Sorry. I opened a wrong tab. Thank you. Mm, yeah, that's right. Correct. Yes. Yes, memory hierarchy. Maybe I went to that wrong course of it. Yeah, thank you. So let's have this one. So basically, before directly going for memory hierarchy, let me share one more tab, because you need to understand, how really the memory hierarchies are working. So let me have that sharing another one. What I want to share is, so I want to share a rough book. I think that's visible, right? Yeah, that's visible, right? Yes, great. So look at here. So memory hierarchies, whenever you want to discuss about memory hierarchies, basically, if you could look at the memory hierarchy, how it looks like is, the top level, the memory storage unit is CPU registers, where the CPUs just put the instructions and then they will process immediately. So before it, there is a cache memory is there, cache memory. And then we have that main memory. Of course, someone says that the main memory is, uh, you know, it might be RAM or ROM or DRAM, all the stuff is there, right? This is the next level. I can say that this is the top level and this is the next level based on the performance I'm talking about, right? This is based on performance criteria, performance, the faster performance. Yeah. So then we have that fixed disk. We can say that fixed disk, it contains that secondary memory, it contains that, uh, you know, uh, SDDs are there, where it is storage, and HDDs are there, hard disks are there. Yeah, these are. Yeah, this is what actually the memory storage. In the based on performance, the CPUs have higher performance. Then that next below that it is cache memory, then main memory, then fixed disk. That's called hard disk, where you have huge memory storage but slower in performance. This is for just understanding. Yeah, let me go back to my things, right? This is what I want to do that. Yeah. So I'm going back to this particular activity. So you can have a look. The 7.1 completely talks about the memory hierarchies, how they are. So you can have the first question, because directly I cannot jump into the question, so that I should understand what is the background of it. Just myself, it is recollecting. So which of the following statements are true about CPU and registers, right? CPUs contains that registers. It's a part of the CPU. It's a less memory space, but faster performance. Current executing instructions are there. So the first one is true statements you need to find out. CPUs are used to store data and instructions that are being immediately processed. Just I discussed. Whatever immediately it wants to process instantly, that content is there. So every instruction, let you consider 15 instructions you operate in. First instruction is available in the CPU registers. That one only it will pick up and it will execute. Then it will fetch the second instruction from the main memory, then put it into the CPU registers, then CPU. That putting into CPU register job is done by the operating system. That is out of the context. But right now, CPU store the data and information which is immediately to be executed. And the second one is registers are located in CPU. Yes, they are part of the CPU. They are not additional component. They are inside of the default of it, right? Registers are used store the permanent of the data, right? It's not right, because as and when the processing is over, by CPU is completed, it will be vanished. What we can say is that it is not a persistent data it can store, only current processing one, temporary storage, what I can say that. So this C is wrong. And the third one is registers are present in small number in any processor. Yes, the CPU registers are very small. Maybe you can say that they are available in 1 KB or 2 KB, not even in NBs, right? So whatever the current instruction, current data is processing, that data is available. They are very small. Performance is faster, but storage is very less. So I think you got this point, right? I think if you have anything, you can raise up your hand when I'm discussing, if you got any doubt, right? Yeah, because mostly this particular 7th week is theoretical, but I will discuss anyway the concept of it, right? Yeah. So now the expanding format of that SRAM. So dynamic RAM is there, static RAM is there. So random is access memory is the static one is there, dynamic one is there. So the S itself is straightforward. It's a static one. We cannot say it's stable or simple or sorted. DRAMs are there, SRAMs are there. The name itself, it is expanded format. Yeah. Now the third question, which of the following is again true about that cache memory? As I said, the CPU registers are at top as per the performance, and the next level we have a cache memory. The cache memory, some part of the main memory or RAM, you can bring it to cache memory, some part of it. Why this contains is, what it contains is frequently used applications and instructions are there. Whatever recent, for example, the history navigating of your browser, that is available in cache memory. Whatever recently visited one, the clipboard things, like you're doing copy paste, so that smaller things we are putting into the cache memory. That is what the cache memory. But cache memory is a some part derived from main memory. Yeah, so that is basically. So let's go with which of the following is true about the cache memory. The first one is cache memory is implemented using SRAM. Yes, because it is actual memory. From that some part is extracted, as I said, right? And now cache memory is limited capacity. It's better than registers, definitely no. Better than registers means in storage, in terms of storage, it is better. In terms of performance, it is poor, fast for access. Because cache memory is a bigger storage. So bigger storage is there means performance is slow. So third one is cache memory lies within the main memory itself. Yes, because that's a part of main memory. It is used to store the data again permanently, not at all. Until your hard disk or SDD we are using, you cannot store the data permanently. I'm sure that A and C is the right answers, right? Yeah. So let me go for the fourth one. Which of the following storage elements has that highest storage capacity in general? Highest storage, not performance, not fast to access. It is for
HDD.
yes, executing not that way, right? Large volume of data. It is HDD. SSD is, it can store the data persistent way, but faster but less storage. So which of the following is usually referred as random access memory? So random access memory means currently what instructions you are bringing, that particular entire application is available in RAM. From that RAM, you are picking up some particular part, which is called, into the registers. The registers currently executing, so one or two instructions like that. So here, there is a dynamic RAM is involved. Static RAM and dynamic RAM. Static RAM, you cannot go for expansion one. You cannot create a virtual space for that. But DRAM, it can create, virtual space, like, extended part. That too, the extension capacity is there. So usually then, but actually, whenever you open a CPU motherboard, you can find that dynamic RAM slots are there. You can insert that slots and you can extend that as many as number of memory slots, so to increase it. So usually we can, RAM means we prefer this DRAM only, not static RAM. Static RAM is fixed, we cannot extend it, right? Yeah. Sixth one, which of the following is true about that solid state drive? See, SSDs are permanent storage, that's sure, but they cannot store huge collection of data. Maybe the SSD capacity, you might get it into the market of 1 TB or 500 GB or 256, something like that. So what I can say is, whenever, I want to say that a smaller storage space, a bigger storage space. Whenever bigger storage space is there, the processing takes time, because performance is poor performance. Bigger storage, because the content we can store has huge as much, right? So whereas SSD is there, which is a smaller storage, faster performance. That's a simple kind of technique. Whenever I have given a small 2 feet of place and I asked you to search for a needle, you can easily search it. If I given that maybe 100 feet of place and asked you to search for a needle, it is much difficult. You need to travel all the space, right? So that's the thing. This is the difference you should understand, why SSD is faster than HDD. That's the basic thing. And SSD contains, it's a flash memory, like our flash disk, it is there instead of magnetic disk. HDDs are using magnetic disk. That's what. Yeah. So solid state. The solid state use the flash based memory, where the traditional disk is using magnetic disk. That's the reason magnetic disk takes a lot of time to process. So that's a true. SSDs are non-volatile. Yes, that non-volatile means they can store the data permanently, so that whatever you stored it, you can access even after years. So SSDs are large storage that can store about that several hundreds of gigabytes. Yes, of course, you can store them. That's pretty sure about it. And the next one is that, no, it is all of the above, right? Okay, that's great. Okay. Yeah, because all of them matching to SSD, right? Yeah. Now the seventh one. So which of the following is a valid or true for storage device which stores the data on the computer? Which of them are valid storage devices? They are able to store the data. They did not ask you whether permanent or temporary. So HDD can be used, yes. SSD can be used, yes. Printer cannot be used. RAM, we can use it for storage, but it's a temporary. So yeah, that's straightforward question. Which of the following metrics are used to compare that different storage devices? Yes, correct. See, look at here. There are different parameters we try to compare. So the latency is there and throughput is there, right? And of course, these two are things, right? And one more is density. Generally, we can say that these three are used for comparing that storage devices. So the latency is, it says that the response time, send a request, process it, and return the response. What I say that, process and return response time. Frankly, you can say that how much time it is taking for giving a final response. You send a request, then maybe you said it store something or read something. How much time it is taking? Going there, instruction, bringing the data, how much time it is taking? That is right. So here, uh, high latency means poor performance. This is poor. You should understand, right? And low latency means better performance. Low latency means better performance. So this kind of technical things you must familiar. Now the throughput is the volume of data you are able to transfer. Volume of data you are able to transfer. So maybe in the network cable, or it might be a data bus. In the database, how much of volume of data you can transport? That's it, right? So here, the density, the capacity, what you can say that capacity of storage, like how much storage of data you can store, like how much volume of data, 5 GB, 10 GB, 30 GB, something like that, right? So all these three parameters we are using for comparing, storage devices. These, because some of them good in density, they are poor at, latency. Some of them good at throughput, they might be poor in density, something like that. It happens because throughput is based on your network bandwidth also, because how much bandwidth, volume of data you are able to send it, right? Yeah. Oh, this is a very interesting one. Yeah, as I said, hierarchically top level based on that latency. See, in the pace of latency, how much processing time it is taking and giving you that immediate response. Register is at top because CPU registers are very nearer units in the CPU. So storage is very less, so that pick the instruction and process it. So this could be the top one. We cannot select this and this, pretty sure that. And comparatively, RAM and this DRAM, that's okay. Static RAM is fixed. DRAM can be extended, pretty sure. But HDD bringing this place immediately after registers is wrong, because HDDs are having, high latency. High latency means poor performance. So that I can select the B option. Yeah, that's okay. I think I can submit. Let me check that. What's happening, right? Oh, something I have today. One multiple selection one. Oh, cache memory is limited in capacity, but better than registers. No, I'm not sure that. But so let me check that.
Because it depends on the capacity, not the performance.
No. Cache memory is limited capacity.
No, in terms of capacity, not in terms of performance.
Limited is okay. See, if they want to ask you the option, cache memory has a better storage, right? Better storage. They should not say that limited, right? Every storage is having limited, right? So let me check the Google. Whether cache memory is better than registers. See, something it is confusing to me, right? So can somebody check it? No, cache memory is a better than registers. Registers are faster,
They are faster, but in terms of storage capacity,
Maybe,
cache
maybe,
memory is
maybe that's right. Maybe here the capacity they are asking, but somewhat this is grammatically. Yeah, maybe I'll copy this one statement. Whether the statement is true or right. Just a moment. Is it true? I copied just exactly into the Google. It's a partially correct there. Okay, maybe I don't know. Maybe you're right. Maybe because I might be in ambiguity time. Maybe I'm not sure that. Yeah, that's okay. Because in terms of capacity, you are right. Okay, that's okay. I'm comparing grammatically. Okay, yeah, that's okay. Yeah. So now we are going for 7.2. 7.2 is exclusively the data set. See, before going for 7.2, again, I want to, just I want to discuss that the data set, how really it is happening. Just I want to share that my rough work things, right? Yeah. So I think, yeah, my rough work, I want to share it. I think my rough work is visible. Great. Yeah. See, look at here. See, the data set, as everybody knows that, if you can talk about the data sets, there are the various things involved, right? If in terms of that efficient algorithms, because mostly they discussed about efficient algorithms in searching, right? In searching, hope you know that there is a searching of that linear search is there. Mostly everybody knows that. And there is a binary search is there. Binary search is the most preferable one when you compare to that linear search. But the input is must be sorted. That's a basic thing where everybody knows that. And as well as there is database searching. When you do that, there is a indexing is associated. Indexing mostly on the primary keys it's available, because as and when you create a primary key, automatic index is available. So using automatic index, it can easily do that. Instead of doing a whole table scan, it will do only particular scanning of that particular one, right? So that is what basically, so that indexed columns are faster to check in the, to verify or to search in the queries in the case of database. If it is backend algorithms, you can talk about that linear search and binary search. Mostly that basic things only they'll discuss. They don't ask you that PDSA kind standard of things. So let me go back to again my this. Yes. Say, look at here. Again, I'm getting back to my this. Yeah, I think, yeah, it's visible, right? So great. Say, look at here. I'm going for 7.2. Now it might be video. Yeah, that's okay. Activate. Say, look at here. So whenever you are applying that searching things or anything, maybe they'll talk about little bit about complexities. Complexities, yes. So here, how many steps are required in binary search to search for an element in the memory when n number of elements are stored in the sorted format in the array? So that is pretty easy. Record, it is straightforward binary search they are talking about. So I can say it's a log n complexity. There is no ambiguity here. So yeah, the second question, for an array, n elements are available. Maybe that's the size of the array. So which of the following O notation, big O notation, will give that worst search result as far as that small change in the input concerned? Maybe if you change that input size, maybe, my input size is 5 initially. Later, I might be changed it to some 50, something like this. Later, I might change it to 27. Later, I may change it to 3. The input size is maybe, dynamically you are changing. Yes. So that's what happening. So here, which of the following big O notation will give worst case complexity? The worst case, maybe due to the change in the input size, maybe which one is representing the worst case. So if you can talk about this, this is the logarithmetic. That is pretty straightforward. Logarithmetic is smaller than unit time. Sorry, bigger than unit time. O of 1 is the least, log n is the next one. So then after it n, because n is the next linear time, then we have that n log n. That's a different one. So here the interesting thing they did it, n to the power of k, maybe k they consider as a constant, I think so. What I say that here, either if you consider k is a constant, either n square is better, or 2 to the power of n, because this n square is a quadratic one, cubic one. Maybe n cube if you go, that's a cubic one. But whenever you go to the 2 to the power of n, it is a very large one. What I can say that this, you can say that exponential, right? Is it exponential? This is just quadratic. So whenever quadratic is there, quadratic is smaller or better performance than exponential. So that I can say directly, this is the worst case complexity. Out of all the complexities, which can be considered as a worst case complexity, based on the input size of n. N might be varied because dynamically they are changing. Yeah, that's also pretty straightforward, but you require a discussion. Yeah. Now, n is a constant. They said n is a constant and k is a input size. They said it reverse. I said k is a constant. Here it is. Okay. Then n to the power of k. Oh, that question what I discussed, this is reverse asked it, right? So n to the power of k means it's going to be that exponential. Again, the discussion, it comes here. Yeah, that's okay. Yeah. Now, which of the following set types can be solved with log n time complexity? So the log n complexity, how can you do that one? Which of the following technique you are applying, set type you are applying? So maybe the fourth one, unsorted linked list, you need to traverse each node when you are searching. Unsorted data also linear searching only suitable. Whenever linear searching of these two, definitely O of n only. I can say that sorted array, fourth one, yes, correct, yeah. Because if you have the input is sorted array, I can do it in log n complexity. Yeah, that's okay. So this is one more interesting one here. Say, look at here. There is a data set contains that n number of entries. If an element element is found in k steps, right? K steps, maybe that might be changed time to time with the help of binary search. So binary search they are doing means they might be sorted one. Maybe if you can talk about that, 1,000 elements, sorted input elements are there. I'm searching for some particular key value, maybe some key value, we don't know, some key value. If this key value is found in k steps, what this k value is definitely, I can say that here, actually, frankly, then, if this is the n size, your binary search requires that log n complexity. Log n complexity is approximately within 9 or 10 steps, right? Is it right? 9 or 10 steps, no? Right? So this 9 or 10 steps are required to search for an element and confirm that whether the element is found or not. So this particular k value is either 9 or 10, maybe something like that. This k is definitely less than n. So I can say that k never greater than n, k never equal to n. That's called log n complexity. It's not n complexity. K is definitely less than n. Yes, sure. But k, we cannot go in unit time. It requires definitely log n comparison. So we required is k less than n. I said it is 9 or 10 comparisons to check that array with 100 elements, right? Sorry, 1,000 elements. So I can say that this is sure. I think it's clear. What I discussed is 7.2, right? Any clarification? Can I submit?
Yes,
Yeah.
sir.
Yeah, cool. So let me do that, because this 7.2 is pretty easy. We all talk about only the complexities and searching things, right? Actually, I thought it is they'll discuss about indexing of database also. They did not do that. Yeah, maybe in the 7.3 they might have discussion with that, right? Yeah, that's okay. I think 7.3 is database search. So earlier searching is only the data search. Here it is database search. But anyway, both of them are searching. As I said, indexing is that important thing. So whenever you want to search a huge database is very huge. We have that collection of records, thousands and lakhs and 10,000 records are there. So I want to search for it, right? See, a table or data compound with 3 columns. They created a compound index with index column 1, index column 2, index column 3. Maybe you can talk about they sorted or they created index on ID, name, and date of birth. 3 columns. So what exactly? First they will create the indexes on ID. Wherever same ID is there, maybe name is used. Of course, ID is not this. Let me do that. Name, date of birth, and father name you can consider. That makes sense, right? Yeah. So whenever the name is same, they want to compare on DOB. Whenever DOB also same, they try to compare with father. That's what the searching job or sorting job it will do. So here, what they talked about is 3 indexes are created, which is called compound index. The values in the table are already sorted on index 1. How will the further? Oh, that's what I discussed. If similar sorting things available in index 1, then it goes to index 2. If similar sorting things are available in index 2, then it goes to this. Yeah. So what exactly this one is? All values will be first sorted on index 2, and then entries goes to that index 2 on index 3. That's keep on going. First sorted on index 2, then the entries within the index 2 are duplicate, they'll go for index 3. That's right, because already this is index 1 is already sorted. The values in the first sorted is index 3. No, not at all, because compound index is left to right. This never happens, right? All values can be sorted with only one of the indexes. No. Why do you do a compound index? Compound index is meant for when duplicate entries are there, go for next depth level of that. Further sorting not possible. Yes, it's possible, but it is a sequential order whenever duplicates are there. Yeah. In the context of MySQL, which are the following statements regarding hash tables? See, if you want to just quickly recollect your hash tables, most possibly there is hash table is available with a particular bucket size. Just you can recollect it. This bucket has index positions. You can say that the quick accessing. So this is called bucket size. If you can talk about this bucket size, you can say that it is size of 5. As and when a value it is to be accessed or to be stored, what it will do, this bucket size is there, your value, whatever key value you're taking, that key value mod operation of this bucket size will do that. So whatever reminder you are getting, that particular memory slot, it will store it. This is called, hash tables or memory table direct accessing using a hash function. This is a simple understanding how the hash function it works, right? Yes. Now, hash tables are 1 unit of time because the complexity it goes to 1 unit of time, because computing a mod operation is 1 unit of time. Directly it maps to the memory table. Now the question is, in the context of MySQL, not only this one, any particular database will do hash tables for quick accessing. So which of the following things are true about this? So now the first one is second bit one. They are used only in the memory tables. Yes, memory tables are accessing, right? They can handle comparison throughout the ranges, not at all. If the key is there, then you can do the mod with it. If you have a range of values, you cannot do it. Yes, you can do that. Yes. They are only easy to use with order by? No. Searching. Like where condition you are applying. Whenever you are applying a where condition, if it is hash table is there, accessing time is pretty quick, which is unit of time. So I cannot say it's order by. So they can even work with partial key indexes. No. So indexes, it's not at all related. It's related to the hash function, which is faster than indexes. Yeah, it's a partial key prefixes. Sorry, I'm sorry. I can say that this is right. Whenever memory table fast accessing, you want to do that using hash. Oh, it is 3 bits only. Oh, it's very small one. Yeah. So which of the following statements are true about that memory and storage? So again, the question, it belongs to that 7.1 only. Maybe they referred here. So now that storage component of the computer allows that store the data long term. Yes, persistent data. I want to store the data for a long, for many years. So the data in RAM remains intact when the computer is switched off. No, it is once switched off is done, all the memory in the RAM is vanished. So RAM is same as hard disk? Not at all. RAM is a temporary storage. RAM is temporary storage. Yes, correct. Current program, the variables, constants, all these are resided. It is 7.2 is very easy. Just 3 bits, right? Straightforward bits, right? Yeah. So I think you got the 7.3. Anything you want to ask then on 7.3? Is it clear? I think if it is clear, just you give me thumbs up, right? So that I know that maybe you are in active state. You are not passive, right? Yeah, great. Thank you. Yeah, that's okay. Now, yes, 7.4 is SQL and NoSQL, but directly before jumping into the SQL and NoSQL, just let me share my some other things, right? Yeah, I'm trying to share something else, which is here, my rough work here, my notebook. See, look at here. So here, the SQL and NoSQL, first basically you should know that, right? First, basically, you should know that generally, whenever any kind of data you want to process or store, mostly we use that DBMS or RDBMS, Relational Database Management Systems, where you are having the data is in structured way, in structured format. Structured format means definitely rows and columns. I can say that one. So that rows and columns, when organizing the data, you can easily understand what relation is there between them. So whenever no RDBMS or DBS is involved, this is called, NoSQL. This NoSQL is simply, it is a document database. Document database. So document database means how it looks like is key and value pair. So just like your JSON objects, Java simple object notation, or somebody likes to understand more, it looks like a Python dictionary. The Python dictionary is, key and value pair is there. That's what it is organized. So it is unstructured. What I can say is that this is unstructured. This is a structured format. This is a basic difference between SQL and NoSQL. Just for understanding. Now we'll walk through the questions. Yeah. Again, I'm going back to my, this one. Yeah, that's visible, right? Yeah. Now we are going for 7.4. Let me see that. Yeah, see, look at here. Which of the following statements is true about SQL? As you know that SQL means structured query language only. Definitely it is not a simple query language, the structured query language. So now the second one is structured query language. You use it to query that unstructured databases? No, it's a structured database. Always it works with DBMS and RDBMS. It doesn't work with other things, right? SQL can be used for querying spreadsheets? No. Your spreadsheets are a different kind of thing, like CSV files are a different kind of thing. SQL database is a collection of tables. Yes, correct. And that stores that data in a structured data, like rows and columns data format is there. So that I can say that D is the right answer. Now, which of the following is or are not a type of relational database? It is not a relational database, just it is unstructured. I can say that, not a structured. Document database, as I said, what is NoSQL? What is that? Key value pair? Yes, it's a key value pair. Graphs, I can say that, graphs. what I can say, yeah, it's okay. Graphs, because if you can see that graphs, it looks like, there is a vertices are there are edges are there, these things are associated with adjacency matrix or adjacency list. Whenever, if you can talk about adjacency list, again you have a key and that key contains a list of adjacents, so you can consider it. But I'm not sure about time series database, whether it is not a relational database or not. But let me make it pending, because time series database involves various things. If you can talk about the weather data, there you might have that city and then followed by longitude, latitude, time to time that updates you are getting. So maybe it requires that structured data, but I'm not sure. Let me put it pending, because I'm not sure. Because if you can talk about that weather data, there is a city is available. This city, it might contain that various weather, temperature things or pollution things, whatever it is, right? This way, if they want to maintain, they can call it is a NoSQL. So instead of it, if they will maintain a rows and columns way, they can have like this, right? City is here. This city is having various readings, right? Like, temperature, pollution, all these are, I can have this here. In this way, if they will maintain, they can consider it is a structured database. That's the reason I'm not sure, but let it be pending of that. Now, third one. So, which one? Which of the following is an example of See, now the most famous and most demanding NoSQL database or document database is Mongo. This Redis is, it's a database, but what exactly it will do? A temporary database. It creates a cache database, but it does not mean that it is a NoSQL database, right? Berkeley DB is a fully structured RDBMS. And memory cache is a different thing. Memory cache is a different thing where it is not related to databases. But MongoDB is a pure document database where it can store the data in key and value pair format. You can say the JSON format. Now, fourth one. Yeah, fourth one is which of the following statements is true about the document database? As I said, document database is key and value pair. MongoDB is an example for document database. Yes. Now, document databases are mainly used to handle large volume of structured data. No. Unstructured data, if it is large volumes, Mongo is better. Structured data with large volumes is that you go for DBMS or RDBMS. A document database is designed to store and query as JSON like document. Yes, JavaScript object notation. I think Java simple object notation. I'm not sure that the expanding format, but the JSON is correct. Yeah, document databases are the types of relational database. No, it is NoSQL. So I can say that A and C is right. Which of the following is correct with respect of storing the data in graphs? See, graphs data, we try to maintain the data in, social networking, like, cities between that there is a cost or fare is involved where you are traveling railway track or something like that, right? Yes. Now, it's different kind of different applications where you are using graphs data. The data in the social networking can be stored, yes, because one, you might have multiple friends or mutual friends, something like that. So I can say that it can be used. Storing data that will involve that different degrees, like, yeah, that is already graphs itself, it is telling. Correct. Now, data stored key and value pair, I don't think it is no, because graphs is meant for in degree and out degree, or you can say that relationship. It's not linked to key and value pair. In the graphs, path finding is more important. Yes, that's the purpose of it. We try to find out the shortest path. We try to find out that minimum cost. So that's the purpose of why the data we use it for the graphs is. Yeah, let me submit this. Oh, something what I guessed. where it is partial. Yes, I think time series also they consider it is JSON data, or what you can say that, document database. Maybe that they are not using relational database. Yes, correct. I think you got the 7.4, right? Any clarification on this? 7.4? Just raise up your hand if you have any clarification. Otherwise, I can proceed for it. Is it clear? Yeah, they're great. Mostly I said it, right? So it is less practical, more theoretical. The 7th week is less practical, more theoretical. Yeah, that's now we entered into that another part of it. I can do that scale up and scale down things. See, that's they are talking about that 7.5. Scale up and scale down is a simple concept. So let me share my rough work again before going for this activity questions. Yeah, this is my rough work. See, height of this, yeah. See, look at here. So here the thing is scale up and scale down. See, actually your web server is there. Initially your web server is meant for to handle 10,000 users, 10K users. But later your web application became popular and number of users are increasing day to day. So maybe it goes to 1 lakh. Then your server capabilities must be increased, like, storage capacity, processing, all these are, right? These are all various capabilities, right? Various capabilities of this one. So I need to do that to scale up. This called scale up, right? Scale down means whatever the number of requests, if it is reducing at that time, we do a scale down. But you won't worry about the scale down because existing configuration, when it is sufficient to handle less number of users, why to do a scale down? That's enough for us, right? Maybe you are saving resources. Yeah, that is called scale up and scale down. So let me share again, going back to my this activity questions of scale up and scale down. That concept of 7.5. This is 7.5. I think 7.5 is visible. Yes, great. Say, look at here, the 7.5. See, which of the following is correct? See, actually, whenever the data replication we do, data redundancy we have. The redundancy means repeating of data. Same data, you might have another copy. Something like that we will maintain. Data redundancy means maybe the server, you have another cloned copy of server. That's called, redundancy, because that's a term of it. So here, let's understand the redundancy, what it will do is, see, replication is whenever one server is down, you have the chance of another server. But redundancy, whenever the first server is running, you have the multiple copies of same server to handle the load balancing or something. Yeah. So which of the following statements is true? Redundancy refers that the duplication of data to the several places in the database. Yes, because you might lose that particular server due to some kind of natural calamities or fire accidents. So you definitely require. Redundancy is not used for purpose of backup. No, it's a purpose of backup only. That's pretty sure. It is used. Data redundancy decreases that cost of storing and retrieving data. No, because whenever number of duplicates you are creating means cost is increased. Definitely it's increased. So this is the correct one. So several places we are keeping the same copy of things, right? Now, a second one. So here, which of the following options refers to having multiple copies of the same data, multiple places? Yeah. So this is, see, look at here. Yeah, the thing is, they did not talk about that duplicate. They're talking about in the virtue of reducing the server load. The server load they are reducing. What really server load is, I can say that one. Here, the server 1 is there. It might be a server 1. Same clone copy of server 2 is there. same copy. For example, this capacity of the server is 10K users. Later, maybe another 2K users are entered. So it cannot handle by the server one. So then what happened is this 2K users will interact with server 2. So that what happened, it is a load balancing, it can be done. So in that case, the data replication, it comes. So if the first server is not able to balance the load, then the distribution of the load, it goes to somebody else. It is also behaves like an actual server. So that's the reason in the virtue of the server load to handle the load, they are not talking about safeguarding of your data or storing of data. It's not the purpose of storing. It's a main deal of that balancing of load. In that case, replication is right. But data inconsistency is a anomaly of database. Whatever modified data, it is perfectly not able to update to the end user. That's a different one. They are not included here. But replication is the right choice. Now, third one, let's see the third one. Which of the following statements is true? Yeah. So redundancy is used in connection of backups. Yes, I said the backups only. Replication is often used for connection of backups. No, it's not at all. So replication results the server load. Yes, it's for handling that number of users are increasing. Like in the situation of scaling up your functionality, your application is scaling up. So redundancy results that reduces server load. No, redundancy is not meant for it. So replication only. Replication contains various things. It contains similar processing capacity of actual server. It contains that similar storage, similar RAM, all that, whatever it is. Yeah, it is replicating. No, that's it. Yeah, it's exact copy of it, a clone copy. Now, so which of the following statements is correct? Yeah, it is expanded format. So actually, base stands for basically, I'm not sure about it. But thing is, this ACID acronym everybody knows about, right? Atomicity, and then consistency, isolation, durability. These are the properties of any DBMS system. Any database management system, these things must contain these properties. Those are called ACID properties, compulsory properties. So that property is expanded format. If you can refer the Google, you can get it, the ACID full form. So it is matching to here, just a acronym or expanded format they asked it. Yeah, that's clear. 7.5. Yeah, that's 4 score. I think it's clear about 7.5, right? Is it clear? Any clarification? I think 7.5 is pretty straightforward. They did not talk about great things, right? Yes, because only the replication and redundancy, you should understand what's the difference between these two. So yeah, nothing else, right? Now, 7.6, I think they are talking about security of database. I don't know, maybe security of database, it involves that. There is encryption or decryption, data validation, and sanitation of data. These are things are involved. I think so. So let me go for that 7.6. Because it is just theoretical one. Oh, why they asked about 7.6 is RAMs. Okay, that's okay. 7.6, yeah. Yeah, which of the following statements are correct? SRAM, which is static RAM, has more latency than DRAM. See, more latency means poor performance, but SRAM is faster than DRAM. DRAM is bigger collection of RAM slots. So that I cannot say that first one is true. DRAM is more throughput than SRAM. See, throughput means, as I said, the volume of data we can transfer of that using the database. So DRAMs are a large volume of data you can put it. That's sure about it. You can check it, because the database which is used directly on the motherboard, which is not separated, but whenever SSD is there, which is a separate unit, I need to extensively connect it using a bus, but DRAM is directly fixed on your motherboard, right? Yeah, if you can see that the architecture, you can understand. And now SRAM is more cost efficient than SSD. No, cost efficient means less cost. RAM chips are more costlier than hard disks and SSDs. So if you can compare that, the cost efficiency, higher costly one is that RAM. So when it comes to that, next lowest cost, we come to that SSD. Still, HDDs are very less cost because HDDs are magnetic made. So that HDDs are very cost efficient. But whenever SRAMs are there, they are not cost efficient than SSD. So now, the last one, I cannot say that this is C is true. Among SRAM, DRAM, HDDs are more. Yeah, that's true, because HDDs are very cheaper. You are getting 1 TB or 10 TB petabyte hard disk for less price, because they volume meant for. They did not use it for mostly processing. Processing, if you want to believe, you might go for that SSDs. Yeah. Now the second one. Here the interesting thing happens here. See, they're talking about cold storage. See, the cold storage is a concept of cloud. The cloud, what it will do is it will maintain some storage buckets. Maybe it could be GCP or AWS or Azure, whatever it is. If you are putting your data for long time access, long time means today you store it, maybe after 2 years you are accessing. Such kind of data, if you are storing it, that is called cold storage. So there are different kind of storage things are there. Every storage type, you have a separate price for it. Cold storage is having more price because they need to retain the data for a long period of time. Frequently they are not accessed. So that's you must remember what is cold storages. In terms of cloud, actually it's not belongs to hard disk or SSD. So here the second one is what they're talking about is about the cold storage. Which one is true? The first one is cold storage are designed to store the huge amounts of data. Yes, of course. That is not read very often. Yes, we put the data and we don't want to access tomorrow. We don't want to access within a month. Maybe after 1 year again I'll access. So that's called cold storage. Now, data retrieval is faster in cold storage? Definitely no. Long period of time you are not accessing means they don't give you that efficient server. They will give you that some passive server. They put it. Again, they will access after a long time, right? Cold storages offer that high durability of data. Yes, they show that they want to store your data for a long period of time. They believe that you don't access frequently. They put it in a passive server, just storage, nothing else. They don't provide great kind of processors and all there. Yeah, that's true. Owing to the storage capacity, cold storages are costly. No, cold storages are less cost because frequently you are not accessing. I can put it in a simple passive server with less memory, less processor, but bigger persistent storage. That's it, right? Yeah. Now, oh, this is latency about Amazon. Yeah, that's I'm not sure about it, but definitely high
Up to
latency.
48
High
hours.
latency means poor performance. What I can say, maximum response time. What I can say? I can say 20 minutes or seconds is definitely not there. If it is in
No,
seconds,
sir, 48 hours.
oh, is it? Okay, okay. Then very, latency is very high. That means poor performance. So I can have that, the response from that Amazon Glacier might take 48 hours. Up to that, you can dispatch your task to there and you can relax. And after 48 hours, up to the 48 hours, you can check it. That will process and returns, but you need not wait for the particular one, right? It is processed, but backend. Yeah. Now, the fourth one. Yeah. So which of the following is true about? Yeah, this is protocols. So whenever hypertext transfer protocols you are using, you might have the data of that without secured layer. If S is used, there is a secure layer is there. Secure layer means you can send and receive the data in security socket layers. So that's HTTPS. Now, HTTPS provides that secured sockets which establishes the secured communication between the, of course, now existing any web portal is having that HTTPS only. HTTPS stands for Hypertext Transfer Protocol. Yes, that's okay, but they missed that S. HTTP is same, but HTTPS is different. HTTPS is more advanced, is a security version of that. Yes, that's sure. It's an advanced version of HTTP. HTTPS is one of the one who performs, no, it doesn't do validation. Safety checks are okay, but validation is okay. Validation means, see, if you are entering your email ID, this email ID is a valid format or not, that HTTPS doesn't do. You need to write a front-end script or back-end script to check that whether that particular mail ID is valid, whether @ symbol is there, domain name is there, extension name is there. That's not job of HTTPS. Only a transport layer secured way it creates, but it doesn't do validation. Safety checks are okay. Safety checks are in minimal, without any kind of hackers, some kind of API keys, whether the API keys are transferred or not. So that's all the things it will do, but I am not sure this one. This is definitely not done by HTTPS. So yeah, let's check it that. Oh, great. That's it. Yeah, that's okay. Yeah, that's okay. I think because all of them are theoretical, because it doesn't take much time. So let me go for the practice, because practice one contains some kind of 1 or 2 questions of numerical. No, I think 2 or 3 questions are there. I think so. Yeah, that's okay. Yeah. Yeah. This is okay. See here, basically, the performance things, right? As I said, the performance things are decided by, till now you understood that. Just let me share something else. Something else, right? I'm sharing something else. What I do here is, yeah. See, look at here. The performance of the server, it is based on various things. It's not only based on your hardware, right? Maybe your hardware is so powerful, hardware of server is so powerful, but the performance is not based on only this hardware. There are various things it will contribute for the server performance. That is the algorithm what you are using. So you are using a bad algorithm, definitely bad algorithm requires a lot of time to process. So that use the best algorithms, so where you can reduce the time complexity, and as well as the network bandwidth also one constraint. Whatever the network you are using, maybe you have a strong enough server, but your internet leasing line is very slow, so you cannot process it. These things, like one more thing is network traffic also. How many people are sharing the current bandwidth? These are all the various things it will decide the performance of it. And of course, along with that, there is memory hierarchy which you are using. Memory hierarchy. Whatever memory hierarchical things, DRAMs, SRAMs, memory cache, how much cache you are using, all these are. So these are the various things where it impacts on that performance of the server. Again, I'm sharing my week 7. Yeah, just look at here. This look at here. So here, you read the question. You have a DRAM. It's a dynamic RAM with a bus width of 64-bit. The volume of the data the bus can transfer, right? The data of things it can transfer. Maximum capacity, you can say that. At a clock speed of 1 gigahertz. See, 1 gigahertz, if they are talking about, means it might be 1 clock cycle. within a one clock cycle per what you can say is, I can say that, I can say that 1 gigahertz is 1 GHz, which is that within a second, how many number of instructions it can process. I can say that 1 billion instructions per second. Instructions per second. Is it right? Is it right? Hello.
Yes, 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 sir.
Okay,
As
that's
was it-
that's clear.
as
That's
was
clear.
it, it is.
That's okay, because to understand what is this clock speed, the clock speed per second, it can process clock speed of that 1 billion instructions per second. So, and the operating in DDR, DDR is in the mode of the operations, double data rate. So this is very interesting. 2 values per the clock cycle. Yeah, it is 1 clock cycle. We thought it is 64 bit of data we can transfer. 64 bit of transfer we can do. But your bus is double-sided. Double-sided means you can say that A side and B side, something like that. So I can do that double rate. Double rate means 64 and 64. 128, because this is 2 values for a clock cycle. For a clock cycle, it's not 64, but it's a 128. That means 2 side. One side is 64, but 2 side is going to be that 128. Yeah, that's okay. What is the maximum bandwidth, the volume of data? In gigabytes per second. Oh, they have asked you that. In this particular bus module, this is a bus module, maximum data we can transfer in bytes, gigabytes per second, in this particular module, with a processor of this, with the capacity of this particular bus, how much volume of data we can transfer in gigabytes, GB, capital B, remember, capital B, because that's very sure. 64 bits is a small letter because it is bits, bytes. They want the answer in gigabytes per second. So what I do here is, maybe I want to do some kind of work here. Maybe, some time it takes. What I can say is 1 byte is nothing but 8 bits, right? 1 byte is equal to 8 bits. So, 8 bits, sorry, 8 bits, right? So what I do here is, whenever bytes to bits you are converting means I can do multiplication, but bits to bytes you are converting means you're supposed to do that bits by 8. Is it right? Is it right?
Yes, yes, sir.
So that I can do that 128 by 8 to convert into bits. Sorry, bytes. This is bits, small letter. I want to convert into bytes. That's okay. This is one particular capacity, but within the clock speed, the processing capacity is 1 billion instruction. This could be one instruction size. I can process this 1 billion instructions, per second. 1 billion instructions. So this is called unit of frequency. How frequently it is that. So that what I can do is, I can multiply 1 gigahertz. I can multiply with 10 to the power of 9, because it is equal to this bit. So I can do that. Is it right? Is it right? Hello? Hello? Because it's a bits, right?
Yes.
Hello?
How
This is equal to 1 gigahertz is equal to gigahertz, sorry. Okay, gigahertz. Is it nothing but GB? Because GB is also 1 billion things, right? Is it right?
Yes, yes, sir.
So I want in maybe 1 billion, if I should write it that, maybe I can use it more zeros instead of it. This 1 GB, I can say 10 to the power of 9. Is it right? Hello?
Yes, sir.
Similar way, this one also I can write 10 to the power of 9. Here. 10 to the power of 9 bits, no, right?
Yes, yes, sir.
Yes, sir.
So that this is bits. You're trying to convert this 128 bits into bytes. This 10 to the power of 9 also we need to convert into bytes, right? I supposed to do that. Correct.
Yes, yes, sir. Yes, sir.
So what I supposed to do is, yeah, I can do that finally. 128 into 10 to the power of 9 bits. Okay. This one is a bits, right? So I need to convert 8 into
Sir.
21. No, sorry.
Hmm.
How many? If divided by 8 to 181 or 16. 16 is the answer, no?
No, just let me complete this one. 16 is okay, but how did you get it is this one, right? That's more important. Clear? 10 to the power of 9 bytes, right? This is 10 to the power of 9 bytes. Okay. I can say that this is bytes. They want in GB, so that let's do that. 10 to the power of 9 bytes, right? So I need to convert this one also bytes. So this 10 to the power of 9 bits, I need to convert into bytes, right? So what I supposed to do is, so this particular one, if I do this way, I can get it.
Divide by
Maybe
8.
something like 16,000 or something, right?
Yes.
16 billion, something like this, right?
Hmm.
I think more zeros. I'm not sure about it. Yeah,
Yes,
that's okay. Number of zeros are right. Is it right?
Yes, sir. Same. Yes, sir.
But this complete one is called bytes. Is it right? Correct?
Yes, sir.
Because I divided with 8, no? Right? Is it right?
Yes, sir.
I divide with
Yes,
these
sir.
complete bits. I divide with 8 so that I got bytes. But they asked the answer in gigabyte. So this bytes again,
You were saying that 128 is also in bits and 10 to the power
correct.
also
These
in
two similar measurements only can multiply, right? Is it right?
Okay, sir. That means by multiplying, the product is also in 1 bits, not bit square.
This value we get it bits and we divide with 8. Is it okay? Just check it with calculator.
Okay, sir.
These two, if you multiply and then divide with 8, definitely you get it that 16 billion, some bigger value. That is definitely bytes. Is it right?
Okay, sir.
But they asked that solution in gigabytes. Again, these bytes you need to convert into gigabytes. Correct? If they ask it in megabytes, it is 10 to the power of 8. If they ask it in gigabyte, you need to convert into 10 to the power of 9. Is it right? Is it right?
Yes, sir.
This is for converting into GB. If they ask in megabyte, you need to convert into 10 to the power of 8. Is it right? Because just to check it, to understand better every beginning of that week 1 itself. So to do a calculation is easy. 1 byte is nothing but 8 bits. Just I'm recollecting. 1000 bits, 1000 bytes equal to 1 KB, they said. Actually, it is 1024. But calculation to make it easy, they did in this way. Is it right? Is it right? Hello?
Yes, yes.
So similar way,
Yes, sir.
1000 KBs is equal to 1 MB. So this way they divided. Because to calculate easily in the AppDev standard itself, because 24 thing is not a big number, which is nearby solution is okay. So due to that, 16,000, this 16 billion value, if you divide with 10 to the power of 9, definitely you get that 16 GB, right? Is it right?
Yes.
Hello?
Yes.
So that's the thing. The solution is, maybe I am taking very bigger time, but I have to go for each particular step because it's a calculative part, I cannot do directly with something a short way. So detailed way I want to go. Yeah, I think you got this question, right? Is it clear? Because first you want to multiply 2 units, means then only equal units only you can multiply. Once they multiplied, then we start converting. First we are converting into bytes. From the bytes you are trying to convert into gigabytes. Yeah, that's it. Yeah, that's okay. I think you got it, right? Fine. Yeah.
Yes, yes, sir.
Yes, sir.
Now, yeah. Oh, this is also numerical one. Okay. Yeah. To make you to understanding, it takes time. Maybe solution you can do it quickly. Yeah. See, a magnetic disk operating 7,200 rotations per minute. See, the magnetic disk is definitely, it looks like this. If you check your hard disk, maybe it looks like the different tracks and sectors are there. These are different tracks and sectors, right? This way it looks like. Yes. See, this particular magnetic disk they are using, 7,200 rotations per minute. This is per minute. See, within a minute, this rotations, maybe rotations means there might be a reading unit is there. This is called IO, input output reading reader, just like your gramophone record. Maybe it looks like that. Yeah. So use it for it. The disk can only spin one direction. Yeah, that happens. Why they're talking about two direction, one direction? Yes. Maybe that's to consider, maybe anti-clockwise. I'm not sure about that rotation. Maybe it could be that anti-clockwise to make it easy, or clockwise also okay. Yeah. Okay. Only one spin, one direction with a constant speed of 7,000 revolutions per minute. Okay. That's okay. But within a minute, these rotations are going to be 7,200. Within a minute, it tries to rotate 7,200 times. If the operating system sends a request to the disk controller, maybe they are calling, this is called disk controller. They call it a disk controller. What exactly this operating system only always tries to read the data from hardware, put the data into the hardware, because operating system is a mediator. Yeah, disk controller to fetch the data. What is the worst case latency in milliseconds? Oh, they want to ask in milliseconds. Worst case complexity before it can start that retrieving data. So before starting means how much time it is taking to go for it. Worst case means I can say it is one direction only. Maybe I can take it a different color. Let's consider this is your data. Okay, for example, your data is at this place, right? This blue color. So your data is at this place means it is moving, coming around all this way, and then it is coming. If it is at this place, if this your data is at this place, this is the best case. If your data is at this place, we can say it's a worst case. That's that they want to talk about worst case. Worst case means already that is out of your reading point, IO handle, or it might be disk controller. They said, out of this disk controller, it is crossed. It is crossed means again it requires that a complete rotation to reach that place. I think you got this point, right? The worst case means, is it clear? Because without understanding, we cannot do that, right? How much time it requires to this particular data at this point to reach this controller part? How much time? That they wanted in milliseconds. So actually 7,200 rotations per minute means, let's go for converting here. So I want to do that within a second, because they want in that answer is in milliseconds. We try to convert the 7,000 rotations per minute into seconds. So I can do that 60. Is it right? Minutes to seconds. So if I do 60, I think we can get it 120. Yeah, 120 rotations per second. That's very clear about it. Hmm. So here the data is there. To reach here, we required one rotation only. Is it right? One rotation only. This data, it starts from here, this place, and it goes here to this place. So how much time required for one rotation? Is it right? Is it right?
Yes, sir.
So one rotation, how much time?
1 divided by 120.
Correct, correct. So 1 divided by 120. Okay, within a second, 120 rotations it is going. Per one rotation, how much time it requires? So maybe I can say that 0.08.
But 10 milliseconds, sir.
Yes, yes, correct, correct. But let me complete this one. 0.0 and then this one 8. Yeah, it is okay, divisible. Okay. Yeah, it's 833 or something, right? I think some more things are there, right? This is nearby value. Okay? But this
8.33 million.
this is in seconds because you divided with 120 seconds, right? This is in seconds. They want the answer in milliseconds, right? Is it right?
Yes, sir.
So whenever you want that seconds to milliseconds means I supposed to multiply because higher value are going,
Yes, sir.
right?
Multiple 1000.
Sorry, lower value. So seconds is the higher value and then you are going to the lower, so that I want that more denomination. So I do that. This 0.03833, 83 or 833 multiply with 1000.
1000.
Yes. So what do you got it? It is
8.33 millisecond.
Is it right answer? I'm not sure about it because I my calculation is wrong. But 8 point, because they asked about 8.3 or 8 or I don't know. Maybe let me check it. As per our calculation, I went it, but maybe they expect more digits or 2-digit rounded value because they did not talk about rounding value. Okay, that's okay. That's okay. That's okay. Yeah, that's okay. Yeah, this is question. I think you got this question, right? Because hardware, why should I draw this one? To understand myself is better. That's what I've drawn this hardware. But it could be interesting thing, I think so. Because to analyze and do it. Yeah, that's okay. I think we can go for third question, right? Can I go for third question?
Yes.
Okay.
Yes, sir.
Great. Yeah, third question is, as I said, that the performance things are depend on various things. One of them is going to be a bad algorithm or good algorithm. Yeah. So there are two search functions are there, maybe one linear search, one binary search, something like that. This could be the first search function, which takes the n size as input. 1000 into n plus 200 nanoseconds, it is taking processing time. Maybe some instructions are 1000 and then this one is this one. N is nothing but your varied or your input size every time changing. And second search function is there, n it is taking. N cube is a internal function, it takes time, which is going to be cubic expression. But definitely I can say this is the worst case time complexity. Comparatively, T1, T2 is the more time it takes, or you can say the poor performance in nanoseconds. To operate the input size is n. Yes, n size is every time it is changing. Which function is better? Oh, this is an interesting thing here. See, which function is better? If we show that input size is n is always less than 10. Here there is a benchmark. There is one particular value they've given. 10 is the maximum. They're pretty sure the input size is 10. Okay. Yeah, it is less than 10, right? Less than 10 means up to 9. So up to 9 means directly you can calculate. So actually, what I can do is the first function t of n, I can do 1000 into, directly I want to go just less than value. Just less than value means 9. I can multiply with 9 plus 200. What's the value here? This is 9,000, 9,200. Is it right? This is. Okay. If I take that second one function where it is n cube, so where it is going to be that 9 cube,
824.
9 cube plus 5. So what it is going to be, the 9 cube be 27, and then what's the value?
729.
Okay, maybe 729. In this case, I think T2 is better. But as per
Sir,
cubic,
plus 5 also, no?
yeah, plus 5 I did it.
7
9 cube plus 5.
plus 5, no, sir.
Ah,
9
ah,
cube
ah.
is 729.
Okay. So 729 and then 5 it is 734, right? Okay, 734. Still it is a better performance. What I can say, this is better. I can say that this is better, right? Actually, I can say T2 is a better because it's a direct calculation, but I want to discuss something, right? Yeah, these two things, just let's go for it. Maybe I want to share something else, just quickly to understand what really happening. This is my rough work. Just to understand, because maybe the question they might ask you in other way also. Yeah, here, you can check it. See here, what exactly is, generally what happens is, the cubic one, this is that poor performance. So comparatively, the earlier equation of that, 1000 into 100, sorry, 1000 into n plus 500, 200, right? 200. This is a better performance generally. Is it right?
Yes,
But
sir.
but up to certain value of n only. This is T1 function up to the certain value. What exactly? Just you recollect your big O notation, which is called worst case. There are two particular functions, set functions are there. Let you consider this is green one, and one more is this red color one. Once the certain point, this red color one, where it might be that T2 function, this could be that T1 function, up to this particular n value, what they said, it is n is something like 10 or something, right? Maybe they said about less than 10, right? Up to this point, this T2 function is poor, but certain point after it, definitely the T2 is going to be higher. Let's check what, can you check that n value with 20? Just let me check it because I'm interested to check it. So in this case, 1000 into
Yes, yes, sir.
20 plus
Yes.
200, it's going to be that 20,200. Is it right? 20,200. Yes. Second function is, so
Right.
n cube and then
Very high, sir. Very high. Cubic,
Yeah.
3 power 3. That will
plus
be very,
5
very high.
plus
Yeah.
5 plus 5. Just a minute.
Yes.
So this 20 cube
20 cube,
plus 5.
400.
20 cube is, that's 400, and 400 then again 20, right?
20,000.
How much then?
8,005.
Oh, still it is not a great value. So still this is the better. This is the poor. So let you try with 30.
But sir, T1 is straight. I think it's straight line.
T1 is poor now. Still the T1 is poor, right? Correct?
But in original question, T1 is straight line and this is skew line.
No. I'm not saying about straight line. After certain point, this T2 is rising in exponential way. Clear?
Yes.
What is that point? I want to find out, right? Maybe sometimes they will ask you us a bigger value. Now 10 is a lower value they've given, right? Clear?
Yes, sir. With
Yes,
with
yes.
30 days coming to 10,000 plus.
Let me check. 30, 1030 plus 200. So it could be 30,200. And then this is 30 cube plus 5. So 30 cube is it's a 900 and then it is 930. What could be then? 930? 21,000.
27.
Huh?
27.
27, huh?
27,000.
27,005.
It is better. It's still better.
Still better. Still, this is the better. So let's try with 35. Definitely it crosses. Yeah, can you check that? Maybe 1000 into 35 plus 200. So in this case, it is 35,000, 35,200, right?
Yes, sir.
Now
No.
you try with 35 cube plus 5. What is this?
42,880.
Yes, this could be 42,000.
880
Yes.
plus 5.
This is the particular point. This is that ideal point. This n value may be something like 32, 33, 34. Some point is there. After that, T2 is going to be extremely rising. So they might ask a question. What they might ask a question is, they might ask a question, reverse order. What they want to ask is, see, I'm sharing my assignment. Here it is. They might ask you, instead of this less than 30, they might ask you a question greater than 35 or greater than 34. Something like this, right? Then T1 is the better thing. Hope you got it, right? Hello?
Yes, sir. Yes, sir. Yes.
So please, that you can take about that, right? You know, as and when they said it is one particular value greater than more than, then you check with, if they said it is more than 33 means just you check with at least immediate 34. If you check with immediate 34, you get an answer. That's tricky thing. Yeah. Yeah. But right now 10 is that T2 is poor performance. Yeah. This is interesting.
If there is no any condition, then which
No,
one?
definitely they'll give a condition. They don't want to make it to complicate. Like me, they want to calculate each and every one. No, they don't give it, because it's every particular question is a limited time, right? I spend the time because to understand better why the T2 is better performance until certain point. They will give definitely this value, less than or greater than value. If less than value given it, the greater than value, just check with. If less than they have given it, check with immediate 9. So you get the answer. If greater than value they have given it, just check with immediate next value, upper value. You get the answer.
Okay.
Yeah. They don't give it huge calculation. I did it repeatedly, number of calculations to understand better. Yeah. What they want to say by this question, that I want to make you to explain. Yeah. Yeah, that's okay. Okay, your application is such a way that most of the time you need to look the database entry given in the first name of the person. Yes, we try to look at. Which of the following indexes is helpful? Because first you check with searching based on mostly on the first name of the user or first name of the recorder. Okay, so at that time definitely you required indexing on first name. We don't worry about roll number. They said it is clearly we search by first name of the person. And second suggestible index, maybe you can use other alternative also. Search by first name and then search by last name. Maybe they can do that future kind of extension. You can do a compound index. This compound index also helpful. But this is not suggested because irrelevant. Always they said it is first name searching. First you search by, and mostly frequently searching is on first name. Yeah. Now, which of the following is the types of columns is most difficult to create the index? Yes. See, indexing can be done on basic data types like varchar, integer, float.
So I have a doubt in previous questions. So the question says that we are mostly going to fetch the person's first name. So okay, so that is why we are actually having an index in first name.
Correct. 10 times you are searching on first name very frequently. Maybe 1 or 2 times you are searching on last name, maybe something like this. Last name or some other column, some other etc. column, right? Clear?
Yes, sir.
So most preferable indexing is on first name only. Clear? Okay.
Yes, sir. But what was the need to have combined, I mean,
Correct.
index on
Correct.
first?
Correct. So after this first name, maybe the next searching criteria is on based on last name. Maybe they did not talk about it, but they might be. You can have such a way. You can have a compound index, but the compound index condition is first column should be first name, right? Rest of the columns you can specify anything. Clear?
Yes.
That's what they want to tell.
So my doubt is that if I have already
Mm.
indexed on basis of first name,
Mm.
so I mean, let's say, and I have sorted them.
Yes.
So, sir, the thing is, the last name. How would I sort on basis of last name again, sir? That is where the question. Unless and until the name are same, first name are
Correct.
same.
Correct. 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 So compound index is helpful if and only the same first names are there, then only it is done. But without indexing of compound, for example, you are searching on last name directly, right? Clear? So if it is not indexed column, it takes that entire table scanning, right? Right?
Yes, sir.
So if you have that, you have a searching points for every particular field, but frequently searching one, you put it as a first column. Next low level of frequent one, because the database is not like 10 or 15 records. So whenever the database admin is there, he suggests that some kind of database tuning part and database indexing part. This part, because see how you can improve that scalability of your application is these kind of fixes you're supposed to do it, right? Is it right? See, suddenly 10,000 users to 1 lakh users are increased to your application. Wherever the possibility of fixes I have to do it, one of the fix may be indexing, right? Right?
Okay, sir.
Because the database experts will identify, the logs will identify where it is lagging the application. Whenever number of users are increased to 10K, what I can fix it. This thing, if you take it, maybe you can improve the performance. They might fix it. Okay. Yeah, this is
Sir, so
additional thing they'll put it. Okay.
okay, sir, so what we are doing is we are first indexing on the first name,
Correct.
and then we are creating a secondary index based on the primary index.
Correct. Correct. Based on the primary index only. Perfect.
Okay, sir.
Yeah. See, there are different kind of columns so far you created, like text fields, all these are, right? Now the thing is, some particular columns are there which you cannot, we cannot do it kind of indexing. Maybe you can say that image files are there, there is a video files are there, such things, right? Such things are definitely creating indexes not possible. They create like a file storage, it stores, right? So varchar you can do indexing, yes. Integer we can do indexing. Timestamp you can do it because it's hours and minutes and seconds. But we cannot create index of blobs. Blobs is binary large objects. Binary large objects. See, these are image files, video files, these things cannot create any kind of things, right? I cannot create it. They can be stored as a single unit of JPG file or video file. So that is straightforward. We can prefer any of the columns, but except blobs. Blobs cannot be used. Yeah. Of course, blobs is a concept of DBMS, but they just for recollecting only they said about blobs. Yeah. To store the photos of the users in database, which one of the fields suitable is blob. That's again about blobs only. These two questions are straightforward from DBMS. And now the seventh one is if the database runs completely from RAM and does not store any data on permanent storage like HDD, then which ACID condition will not be fulfilled? See, if you can recollect your ACID properties, atomicity is there, consistency is there, I think integration. What is the last one? I remember.
Durability.
What is that?
Durability.
Okay, durability. See, we got the answer, right? See, it will not be stored into your hard disk. Like you process sum of two numbers, you return the result, you don't put that result into hard disk in a database column or something, right? So at that time, it is a temporary variable. It's a computational variable. So at this time, this D property cannot be satisfied because the durability is not required. Just you calculate and print it. Yeah, that's very interesting one, but it's okay. So which of the following is a better suited for storing connection information on the social networking? So again, we get back to the databases. Document database are there. Graph database, they have in degree and out degree where you can find it that mutual friends, all these are. I can say the graph database. This is also straightforward question. No, this is one other interesting question. Maybe it could be some kind of thing. Yeah. So you have a data center which that each server has 1 Gbps rod, small GB, right? So gigabits per second network connection. Maybe what I can say is you have a server. This server is connected with a network of that 1 small Gbps, right? Gigabits per second network connection. But overall data center has the 10 gigabit per second. Yes. So what exactly your incoming 10 Gbps, it is divided into another servers and another server. You have multiple servers, right? Another server, like like this, you have 10 servers are there. All these are distributed, the incoming line of 10 Gbps line, right? So as an application becomes that very popular, as I said, scaling up, you start getting 10,000 requests per second. You are getting 10,000 requests, and each request needs 10 kilobyte. So kilobyte is faster, large volume than bits, right? So which of the following is the better option? They are asking that how to do the scale up. What exactly, how to handle 10,000 requests per second into 50 KB of that KB, capital B, right? Kilobytes per second. What is the better choice? Better choice means scaling up the single server. Say single server scaling up means what exactly, they don't want to focus on this network bandwidth. What they're trying to focus is, they're trying to focus on the scaling of the server. Maybe they use it, better algorithm. They might use it, indexing in the database. All these are like RAM, they are increasing. All the hardware and software things they want to extend it, scaling up the server. They did not do that any scaling up of this network. This network is just as it is, because network cable, they made it as it is. They did not want to increase its bandwidth. So what is the better choice? Scaling up a single server, like, a single server, if I do a scale up with powerful RAM and powerful thing, not at all. Scaling up multiple servers, like 10 servers are there, I can increase to multiple servers like 11th server, 12th server, 13th server. So if I do keep on increasing, what I do is, I think they're supposed to increase that overall data center, this one also, right? This Gbps also should be increased, right? But this is a better option. This is not a better option. This is a better option. But along with it, they're supposed to increase the overall data center also. Is it right? Hello? Hello?
Sir, shouldn't it mean that incoming 10 Gbps speed is going to remain constant?
If it is constant, already 1 Gbps is been shared by the 10 servers, right?
Yes,
Clear?
sir.
If all 10 servers are sharing, if I increase to 11 server, 12 server, 13 server, number of servers, is it improve the performance, that scalability? Nothing, I think. Because Already this is having incoming line of 1 Gbps. 10 Gbps is already shared. What about 11, 12, 13? Is it require additional bandwidth or not?
Sir, but when we read the question, it doesn't suggest that we are, supposed to increase that 10 Gbps connection speed. The question does not suggest
Correct,
directly.
correct. Does not suggest. I think they're supposed to give a complete question, because the question is okay, but there should be option 1, option 2, option 3 also they're supposed to specify. Option 3 is overall data center, network bandwidth should be increased, so that I can choose option 2 and option 3. Is it right? They're supposed to give 3 options, right?
Yes, sir.
I think 2 options is not sufficient. Okay, maybe there might be some kind of mistake in the question. Question is okay. I'm talking about this particular options. Definitely one more option is required. So I believe that. But right now, this is the right option, because I cannot go for other option, because they have provided only 2 options. Because if I increase that number of servers, multiple servers are increasing, scaling out that number of servers to next. But incoming line is less, means you cannot do it. Okay. Yeah.
Sir, one more thing is missing, sir. The cost associated with these two approaches is also missing, sir.
Maybe I think so. Maybe if you think about that more, again the cost is involved. Okay, that's okay, because we cannot think more on this one. Yeah, because maybe my assumption is somewhat some issue. Yeah. This is SQL injection. See, what happens is, mostly whenever we write that backend code, we write SQL queries. This SQL queries, sometimes we write that hard-coded SQL queries. What exactly SQL injection? I want to talk about that. Hard-coded. Maybe I can talk about a particular SQL statement from the some user, where username, I write that some admin, and password, some kind of, maybe ABCD, something like this one. This is a pure hard-coded. If this were hard-coded, there might be chance of that attackers where they can send this SQL query can be executed through a form. Like SQL injection can be done through a web form. They might send it through a web form. They might send a raw SQL statement whenever your SQL things are hard-coded. So we should not write hard-coded SQL statements in the backend. That is, every developer must know. You should not write it. So here, SQL injection means what exactly? Feeding the SQL from the web form. If you are passing your raw SQL statement from the web form, that is a dangerous one. They can try brute force effort to crack your admin password. That is the thing what is called SQL injection. So hacking the server from the foreign country, no, that is not called SQL injection. So you can Google it. Theoretically, what SQL injection talks about is, so processing the SQL queries in a NoSQL. No, NoSQL also can have that simple kind of SQL statements there using some other UI interface there. That is not considered as SQL injection. SQL injection is a simple concept where it is executing your SQL statements through web form, and you are writing hard-coded things, right? Yeah. Next one is sanitizing the data. So here, if you can see that the sanitizing data is here, maybe you can talk about that, your email ID. See, the email ID, when you are entering, you should require some @ symbol followed by a domain name with extension. This is compulsory. Here you can put it some ID there. After this particular ID's proper format is there, that will be sent it to backend server. If you don't do a sanitizing of this data using a front end, what happens is, this maybe if you typed instead of @ symbol, I typed dash. Instead of this extension, I did not type anything, just I typed Gmail. That's it. That's it. I did not type extension also. This particular email ID is moving from this particular thing and going to the backend, and backend is checking this one, whether it is a proper data format or not. It's a wasting of network bandwidth and as well as the backend. So validation should be done in the front end and backend also, but backend validations are different, front end validations are different. So here the sanitizing data is exclusively checking the particular one, making sure that invalid data, symbols not allowed into the query. Like, this should not be allowed to the backend query. So it has to be sanitized before sending to the backend. So I can say this is right, but this is correct. This is a blind option. You can ignore, right? Cleaning up HTML forms. So only essential data is submitted. No, that is cleaning of cache and cleaning of cookies. That doesn't make a sense of cache memory, right? And then using compression to reduce amount of data. No, not at all. Compression is a different kind of process. Yeah. The next one is sanitizing the data in SQL queries, a responsibility of the end user. I don't think it is end user response. End user is just he will enter the data. Just he will enter. Application developer is more responsible because he will develop front-end framework and back-end framework, right? So both front-end and back-end frameworks, when he is building, you must be able to validate some things in front-end, some things in the back-end. So that is, database administrator is only about fine-tuning of database. Data center operator is a different. He has to take it in uninterrupted power supply and no network issues. All these are he has to take care. But application developer is responsible for sanitizing. Yeah, I think that's okay. You can submit, right? Because this is only that few numerical things, it was taken time. I thought it is more decimal places. Okay, that's okay. I think you got the point, right? Any clarification from your side, please let me know. Okay. Yeah. So thank you. Have a nice day. I think we can close the session, right?
Thank you, sir.
Okay.
Thank you, sir. Thank you so much.
Thank you, sir.
Thank you, sir.